Okay, so we're going to look at section 6.1. And basically what we're going to do is in the last chapter, okay, we have taken a kind of 2D shape, okay, and we wanted to find the area of it. And we used a one-dimensional, okay, we took rectangles and got them so thin that they basically turned into one-dimensional lines. And then when we integrated that, we went from one-dimensional measurements, the line, to a two-dimensional thing, which was area. So now what we're going to do is we're going to go from two-dimensional to three-dimensional, okay? So the idea here is, and you'll have to forget my drawing skills, okay? Okay, so the idea is we are going to take a cross section on this. Okay, so we're going to slice down through this. Okay, and basically what's going to happen is okay, so what we're going to do is we're going to find the area of that shape, and then when we integrate that across the entire dimension or across the entire space, then that's going to give us the volume of this irregular shape. Okay, now there are a couple of different ways, okay, that we are going to do this. Okay, most of the time when we're dealing with this, okay, we are going to deal with well, we're going to start with doing shapes that we know. Okay, so we're not automatically going to start with like some kidney bean shaped thing. Okay, so the first thing that they are going to define, okay, is that volume is equal to the integral from a to b of a of x dx. Now this represents the area of our shape. Okay, so what we're going to do is we're going to have to find the area function, and then we're going to integrate it over our bound. Okay, so now the first one that we're going to look at, okay, and we're going to work with things that we know. Okay, we've got a pyramid. Okay, it's 3 meters high, square base, that is 3 meters each side. Okay, now then, let's think about this. I'm going to draw this as best I can. Okay, so here's our square pyramid. If I cut a cross section into this, okay, the shape I'm going to get on that cross section is a square. Okay, because think about it. This is basically just a square stacked on another square, and each square is getting smaller. So this cross section is a square. Okay, so now when we do this, okay, if we think about how high we are from the top, okay, so if we think about it, up here at the top of our pyramid, I'm just going to draw the front face of this, okay? We know that down here across the bottom, this is 3 meters. We know up here at the top, if I was going to measure the side, it would basically be 0, okay? So at any point here, my length is x. But that means that that's also x. So my area function is going to be x squared, okay? So now our integral is going to be, and we're going to work our way down the pyramid, okay, is from 0 to 3 x squared dx. Okay. Now, this is going to integrate back up to 1/3 x cubed evaluated from 0 to 3. So we're going to have 3 cubed, so that's 3, 9, 27, okay? So 27, and then 1/3 of 27 is 9 minus 0, so that's going to be 9 meters cubed when we get done with that. Sorry. So there's our volume. Okay. So taking a look at another one, okay. Okay, so we've got a curved wedge, cut from a cylinder, okay, which has a radius of 3, okay, by 2 planes. One is perpendicular to axis of cylinder. The second is a 45-degree angle at the center. Okay, now let's get an idea of what this looks like. Okay, so first off, cylinder. Okay, now what they're saying is the first one cuts right here across the bottom. Okay, so the first plane is right here across the bottom face of this. Okay, the second one, okay, comes in and intersects this lovely little bugger at a 45-degree angle when it slices through. Okay, so now I'm going to try and draw this a little bit better on just the wedge shape that we've got. Okay, so okay, so now let's do a cross section. You can kind of see this one. Okay. Now this comes down, that comes down. We got this cross line. Now, I'll set this into a plane. Okay, let's set this at the origin. This is at -3, that's at 3 because it talked about it having a radius of 3. We also know that this outside edge is back here at 3, okay, because it was built off of the cylinder. So we've got that kind of a radius, okay? Now, let's talk about what all this is. Now, this bottom curve, okay, and I realize mine's a little elongated, okay, but guys, that is a semicircle, okay? That is a semicircle. So, the equation of that semicircle, okay, oh, sorry. The equation of the semicircle, think about, for the full circle, it would be x squared plus y squared equals 9. So if we do y squared equals 9 minus x squared, y equals square root of 9 minus x squared, okay? So there's our semicircle, okay? Now, if I want to figure out, we need to talk about this rectangle right here, okay? Now, if I come out this direction to x, okay, that means this vertical is also going to be x because that's a 45. Okay, so because we know 45, 45, 90s are x square root of 2. Okay, now we need to talk about what is this length. Okay, now looking at this, lots of colors here. Okay, this edge down here, okay, kind of from the center to the bottom, this location right here is going to be at x negative square root of 9 minus x squared. Okay, that's our ordered pair, which means that one up there at the top would be at square root of 9 minus x squared. So this top edge is 2 square roots of 9 minus x squared. Okay. So now let's talk about we're using a rectangle here. Okay, so I'm going to get rid of some of my loveliness up here at the top. Okay, so we are doing the integration from 0 to 3. Okay, of area formula is going to be base, so 2 square roots of 9 minus x squared times our height, which is x, okay, dx. So we've got integral of 0 to 3, 2x square root of 9 minus x squared dx. Okay, so guys, we're seeing some substitution in here. Okay. Okay, hopefully you kind of see it. Okay, we've got 9 minus x squared. Derivative of that is going to be, now granted, it's a negative. Okay, so here we go. I'm going to let u be 9 minus x squared. Du dx is going to be negative 2x. So negative du equals 2 dx. So now I'm going to integrate. Okay. Let's see what's going to be square root of u negative du. I'm going to pull the negative out into the front end. Okay. Integrate. Now, I have left off my bounds because I'm going to go back to the 0 to 3 here in just a minute, okay? So that is u to the 1/2 du. This is going to be negative. That's going to go to u to the sun, and it's back to 9 squared to the 3/2. I'm going to evaluate that from 0 to 3. Okay. So if I plug in, I have negative 2/3 times 9 minus 9, so it's going to be 0 to the 3/2 minus negative 9 minus 0 to the 3/2. Okay, this is going to go to 0 up here on the front end. We're going to have plus 2/3 times, okay, 9 square root of 9 is going to be 3, and then cube is going to be 27. And then 2/3 of 27 is going to be 18. And this was in, it doesn't specify, so units cubed. Okay. Because we do need to make sure that we're kind of doing, appropriate units. Okay. So now the next one that we're going to look at, okay, is what's called discs. Okay. And the idea here is that we are taking an object. Okay. I'm going to do just a rough reference here. Okay. We're taking a curve. Okay. We're going to spin this thing around the x-axis. Okay. So now we're getting a shape that is solid, but we have circles, okay, as our cross section. Okay. So this looks kind of like a U-shaped bowl that's solid all the way through. Okay. Now, in order to find the area of that circle, okay, we would need to know the radius. Okay. Well, the radius is here out. Okay. So we know that the area of a circle is pi r squared. Okay. So now, but the radius is being defined by the function. Okay. So what we now have is pi some function. Okay. That's going to give us our radius. squared. So now here's our equation. So now if we want to find volume, this is the integral from a to b of pi okay? And this is what's called using discs, okay? So this is discs, okay? So when we do this, okay, they are gonna say that we're revolving it around, and guys, you're gonna have to watch which way they're spinning it, okay? Because if they spin it around the x-axis, then our functions need to be in terms of x's. If they decide to spin this thing around the y-axis, your equations need to be in terms of y's, okay? So we got to watch that, okay? So we're going to do the region between y equals square root of x from 0 to 4 and the x-axis revolved around the x-axis. So this is going to be very similar to that picture that I just did, okay? To generate a solid. So, quick picture. Here, here, here. So here's our square root curve. And then if I revolved it, I would have a solid that looks like this, okay? Here's kind of our solid. So we are integrating from 0 to 4, because we're moving this way, out across the x's, of pi, and then our radius is square root of x, that's our radius, squared, dx. So this is the integral from 0 to 4 of pi, square root and square are going to cancel each other off, so it's going to leave me x dx. Okay, now pi is just constant, so this is going to integrate up to 1/2 pi x squared, okay, evaluated from 0 to 4. Okay, so we've got 0 is going to make everything go to 0, so I've got 1/2 pi, 4 squared is 16, so it's going to be 8 pi units cubed. Okay, and there's where we get our answer for that one. Okay. So now, let's look at another one. So now, we're going to do the circle, x squared plus y squared equals a squared, rotated around the x-axis. Okay, now, if we think about it, a circle, when it spins around the x-axis, is going to make a sphere. Okay, so it's going to make a sphere, and we want to find its volume. Okay, so now, thinking about shape here, we are looking at, here's a, negative a, and negative a. So here's our circle, okay? And we're spinning this, so it's making a solid sphere as this goes around. So now let's talk about how we're doing this. Now, granted, okay, that if I took the top half of this, okay, if all I had was the top half of this, okay, then that top half, that semicircle, if it spins, would also create the same shape. So the upper side of that as an equation, okay, similar to what we just did, I would have y squared equals a squared minus x squared. So y equals a square root of a squared minus x squared. Okay, so there's going to be, that is going to be our radius function. Okay, so that's going to be our radius, because that's going to give us up. Okay, now we can do this one of two ways. Okay, one thing is that because we know it's a circle, okay, we know that circles are even functions. Okay, so two options that I have. One is I can go from negative a to a, so from here to here, okay, of pi times our square root of a squared minus x squared squared dx. Okay. The other option that I have, okay, is that because it's even, we know that I could do 2 times the integration from 0 to a of pi. Now notice I'm only going from 0 out this time, of square root of a squared minus x squared squared dx. Now I'm going to work with the second one because it's an even function. Again, square root and square here are going to go away. Okay, so I've got 2 times the integration from 0 to a. And I'm going to go ahead and pull the pi out here to the front too, okay, because it's just a constant that we pull out. So I got a squared minus x squared dx. So this is going to go 2 pi times a squared x minus 1/3 x cubed. Okay, and we're evaluating from 0 to a. Okay, so I've got 2 pi. If I plug in a, that's going to be a cubed minus 1/3 a cubed. If I plug in 0, everything's going to go to 0. Okay, so that's going to give me that's going to be 2 pi times 2/3 a cubed, which is going to be the 2 will multiply in. That's going to give me 4/3 pi a cubed. Okay. Okay. Now, sometimes, guys, what they're going to do, okay, is they're going to change where that line of rotation is. Okay. I hate to say it, but sometimes they're going to do it. Okay. So, we're going to look at, we've got the volume. They want us to find the volume of the solid generated by revolving y equals square root of x and y equals 1, x equals 4, about, that just means around, y equals 1. Okay, so first off, let's get a picture. Okay, first off, this x equals 4 thing, that's going to cut our shape. Okay, now this curve is here, and we're cutting this here. Okay, so we're revolving this, okay, around that black line. Okay, so now we need to think carefully about what that radius equation is going to be. Okay, the top part of this is square root of x. Okay, now the radius then, okay, if I was going to do a radius out of here, okay, would be square root of x minus 1. Because whatever this is, so let's go out here at the edge. If I picked it 4, we're at 2, but that distance would be 2 minus 1. That's a length of 1. So this is going to be our radius. Okay, so now we are going to have the integration from 1, okay, because here's, I'm only going from here to here. So that's from 1 to 4 of pi times square root of x minus 1 squared, okay, dx. Now, we can do a little bit of mathing here, okay. I'm going to bring the pi out to the outside just because I don't want to deal with it on the inside. Okay. Foiling this, square root of that is, or squaring that is going to give me x. It's going to give me minus square root of x, so minus 2 square roots of x plus 1 dx. Okay. I'm going to switch this to x to the 1/2. Okay. So now I've got pi still sitting here on the outside. It's going to go to 1/2 x squared minus. Okay, now that's going to go to x 3/2. That means that 2/3 is out in front. With that is going to be 4/3 plus an x evaluated from 1 to 4. Okay, so now use calculator here to help me out. Okay, I'm going to do the 4 part of this. So half of 4 squared minus 4/3 4 to the 3/2 plus 4. So I've got pi, and then that is 4/3 minus, and then I'm going to do the same thing but with a 1. That is a 6th. So 4/3 minus 1/6 is going to be 7/6. So I've got 7/6 pi. Okay. Again, one of the most difficult parts of this is making sure that you know exactly what the radius is and how that's going to sit. So drawing a picture is probably going to be key to making this happen. Okay. Now, the other thing that I said, okay, back earlier is when they spin around an axis this way, okay, so around something like the x-axis or a horizontal line, then all of our functions need to be in terms of x's. If they decide to spin around the y-axis or a line like the y-axis, okay, then we have to change up our shaping, okay? So now, if you're going to go around, so rotation around the y-axis, okay, we're going to integrate from C to D, and they're just picking different letters. Now, this would be like bottom to top, okay, of pi r of y squared dy, okay? All we're doing here is changing it. Now we're going to be in terms of y's instead of x's, okay? So we are going to look at okay, so we are doing y-axis, x equals 2 over y, and we're going to go between 1 and 4, and we're going to go about the y-axis. Okay, so again, picture here. Now, guys, this is a rational function. Okay, so if I put in the number 1 for y, I get 2. So it's going to be here. If I put in the number 2, I get 1. And if I put in the number 4, I get a half. Okay, so kind of a rational curve here. Here's this, here's this. Okay, so when we spin this, I'm going to draw it out here on the other side. Okay, it's kind of a volcano looking shape. Okay, kind of a solid volcano looking thing. So now the radius goes out this way. Okay, So that radius is going to be that 2 over y thing. Okay. So now let's talk about, we're integrating from 1 to 4. Pi times 2 over y squared dy. Okay. So now, again, a lot of times we do pull the pi out just so that we're not having to worry about this, okay? Now, this is 4 over y squared dy. Now, I'm going to write this slightly differently for us. Okay? So, we are going to have 4 pi, I'm going to bring the 4 out. Okay, guys, -2 is going to go back up to -1, and then I need to pick up a negative because it was positive, evaluated from 1 to 4. Okay, so now I have 4 pi. So -1/4 minus -1 over 1. Okay, so that's going to be -1/4 plus 1. So it's going to be 3/4. So I have got 4 pi times 3/4, which is going to be 3 pi. Okay. So now, same thing that they did with the x's. They can move these shapes, still rotating them around a vertical line, okay, but they can shift where the thing is, okay? So we're going to look at the parabola, x equals y squared plus 1. We're going to do the line x equals 3, and we're going to go, sorry, x equals 3, and we're going to go about or around the line x equals 3. Okay, so here we go. Let's get this lovely shape going here. Okay, now that is classic sideways parabola. It has moved one space to the right because, again, everything is flip-flopped. Okay, so we're here, here, so here's our parabola. There's our line at x equals 3. And then we're going to spin this, and again, it should be a little more rounded from the bottom. So then our other shape's gonna, our other half's gonna look like this. Okay. Now we're doing, okay, the shape is going this way because again we're working up and down here. Okay. So now we need to figure out where is this, like what is this point right here. Okay. Now we know that that's at x equals 3. So we're going to set going to move the 1 back. So this is square root of 2, negative square root of 2. Now that's going to help us out because now we're going to integrate from negative square roots of 2 to square roots of 2. Okay, now let's figure out our radius. Our radius is going to be, okay, now you got to think about which one's further out, okay? The line is at 3 minus the closer one, y squared plus 1 squared. Okay, so let's clean this up. So it's going to be minus 1. So this is going to be 2 minus y squared squared dy. Sorry. Okay. Now, again, I'm going to bring my pi out here to the front. Negative square root of 2, square root of 2. I'm going to FOIL this. So 4 minus 4y squared plus y to the 4th dy. Okay, so now we've got pi. We're going to go to 4y. It's going to go to y cubed. So I need a 1/3 out in front. So it's going to be 4/3 plus 1/5 y to the 5th. And that's being evaluated from negative square roots of 2 to square roots of 2. Okay. So I'm going to, again, use a calculator to help me out here. So I've got pi times okay. Hey guys, I did some, because I saw that square roots of 2 in there, I did some lovely little, like I got a decimal answer of like 3.0169. I divided by square root of 2 and then was able to convert the fraction. Okay, so now I'm going to bring in and get the negative version of this. And I'm getting negative 32 over 15 square roots of 2. So it's going to turn into plus. So I'm going to have pi times 64 over 15 square roots of 2. Okay. Now, I would certainly take the decimal version of that. Okay. So if you gave me negative 6.034 pi, okay. So if you gave me something like positive, 6.034 pi, I would be perfectly acceptable with that. If you gave me 18.956, which is the actual like multiplying out with pi, I would take that too. Okay, I'm not necessarily always going to be looking for this exact precision answer to be given to me. Okay, unless it like super specifies, make sure to leave answers in fraction form. Okay, I am not going to fuss with stuff like that. Okay, now sometimes what happens, okay, is when we spin something. Okay, so let's take this. Let's go back to that example, okay, where they cut this off here. Okay, so this was our square root function, and this was the line y equals 1. And they spun this around the x-axis, okay? What we're going to get, okay, is we're going to get something that's got a big hole in the middle, okay, like a big donut, basically, okay? So what we're going to use is what's called the washer method, okay? Now, the idea is if I take a crosscut on this, I wind up with something that looks like this. Now, the difference here is I'm going to need to figure out, okay, and this is what we need is the orange, okay? Now, you go back to geometry, this looks like area of shaded regions. You're going to have what we call big R, and then you're also going to have little r, okay? So the way that the washer method works, okay, is we're going to integrate from A to B, pi, since both of those would be pi's, big R of x squared minus little r of x squared dx. Okay, now this is, we are literally just adding, okay, the fact that we are now going to have a hole in the middle of our shape. Okay, so let's take a look at one of these. Okay. So we are going to do y equals x squared plus 1, y equals negative x plus 3. We're going to go around the x-axis. Okay, now the first thing that they don't tell you here, okay, is your bounding. So that's the first thing we got to figure out. So classic parabola, we are getting terms of x, so we just went up 1. So I'm going to graph me some points. Okay, so there's that one. And this other one in this. So we are at 3. Sorry, that's 4. 3, down 1, over 1, up 1, over 1, up 1, over 1. Okay. So there's our line. Okay. And so this is our solid. And again, we're spinning this around the x-axis. So what's going to happen is, if we're going to look at our shape, okay, so we've got this kind of vase shape in the middle that's the hole, and we've got this solid shape on the outside. Okay, so now we need to talk about outer radiuses and inner radiuses. Okay, so big outside radius is going from here all the way up to here. So big R of x is going to be the negative x plus 3. That's up there at the line. Little r is going to be this inner radius, and that is going to be our x squared minus 1. Okay, so now, and we are working from -2 to 1. Okay, so we're going to integrate from -2 to 1. Pi, okay, big radius minus little radius, okay, pull the pi out again. Now, I'm going to clean some of this up. I'm going to FOIL it all out, and then we're going to see what we can do with it. Okay, so squaring this, I'm going to get x squared. It's going to be minus 3x minus 6x plus 9 minus, big set of parentheses, x to the 4th minus 2x squared plus 1. So then we've got -2 to 1. Combine this up. So I've got negative x to the 4th. Okay, I've got x squared plus 2x squared. So that's going to be plus 3x squared minus 6x. 9 minus 1 is 8. Sorry, I'm making sure I did all my math right. Yep, I think that's right. Okay, so now we've got pi against negative 1/5 x to the 5th plus x cubed minus 3x squared plus 8x evaluated from -2 to 1. And again, I'm going to use a calculator here to help me out. Okay, so I've got okay, so I get 5.8 minus, and then I'm going to come back in. Negative 29.8. So we've got 5.8 plus 29.8, 29.6, sorry, 6, gives me 35.45. Okay. And we'll do one more example where they are going to rotate around the y-axis. Okay. So we're going to do one more where they revolve around the y-axis. Okay. So we're going to do the parabola y equals x squared, line y equals 2x, first quadrant. Okay. And then we're around the the y-axis on this one. Okay. So here we go. Drawing a picture. Classic parabola. We only need first quadrant, so I'm going to put that there. And then our other line is 2x. This is a sign, so it's this little shape. And so when we spin that around, okay, we're getting kind of a V cut through the middle and a rounded bowl. So kind of a round bowl with a V cut out of the inside. Okay, so again, we're gonna have to talk about this in terms of away from. So big R. Okay, now this needs to be in terms of y's. Okay, so that just means I need to bring square root. So it's gonna be square root of y over little r is going to be here. Okay, now again, this needs to be in terms of y, so that's going to be 1/2 y. We are bounded low at 0, high at 4. So we are going to integrate from 0 to 4 pi big R squared minus little r squared. Again, I'm going to bring my pi out to the front, 0 to 4. I'm going to clean this up. So this is going to be y minus 1/4 y squared. Okay. So integrating that, I've got pi 1/2 y squared minus, okay, now it's going to go up to a third y cubed, so that means I need a third of it, so 1/12 evaluated from 0 to 4. Guys, if I plug in 0, it's all going to go to zeros. Okay, so I need the 4 part of this. So let's see. 1/2 4 squared minus 1/12 of 4 cubed gives me 8/3 pi. Okay? Because again, guys, if I plug in 0, it's all going to go to 0. Okay. Now, I know that was a lot. That is a lot in a section. Okay. We did cross sections, we did discs, and we did washers. We also did rotating around the x-axis, around a different horizontal line. We did around the y-axis, around a different horizontal, vertical line. Then we did washers, where we have kind of this double radius thing. Okay. So if you need to, okay, you can always shoot me an email and stuff like that if you get stuck. Okay.